Hello, hello. Welcome to the first stream, or first live stream that I've done. So this could be interesting. Last time I did one of these architecture kind of tasks, it was recorded, even though I rambled for like an hour in front of a camera. This one is live and rambling in front of a camera. So what we're going to be doing today is we're going to be taking a look at a common system design task that you may get. This one is a live FX/stock ticker API. We're going to be taking a look at it from the perspective of a system design kind of point of view. So we're looking at what technologies we're using, why we're using those technologies, roughly how we would go about designing the solution, and some other bits and pieces. Now, we may go into different bits later on as I get used to doing these kind of streams. But first one is just going to be a very high level kind of API that we're going to go and design as if it was a systems architecture. So let's take a look at the scenario that we're going to be doing today. So this is the task that I've kind of pre-written. It's accurate as if you would. This is sort of the brief you would get in an interview. So let's go through it quickly. We've been hired by Contoso Stocks, a global stock trading company, to redesign their existing stock trading information endpoints for their customers. The existing system has multiple ingestion sites around the world and high traffic demands at certain times of the day. So two key factors that I'm looking at here. One is the multiple ingestion sites. The other is the high traffic demands at certain times of the day. Now, between these two, this does indicate a kind of multi-region design. And there's a couple of ways that we can do this. We can try and go active-active across the whole globe, or we can have a single kind of active region and the rest kind of replica regions that are just going to consume their data from other places. And there's pros and cons to each one, and we can go through that as we go through and design the system. So the system must ingest data from regional data sources such as NASDAQ or the London Stock Exchange, but it should be available to everyone globally, again, fitting into that kind of multi-region design. We need to take a look at providing the information via a live API and a historical API. Given that it's a live API, we must display the current stock value within a second of it being received. Otherwise, the value is not going to be there. The historical API must be able to display values for at least the last day, last month, last year. So we're looking at some kind of aggregation here that we're going to have to do as part of this task. When we're looking at kind of per day, per month, per year, that's obviously quite a lot of data. So the interviewer has asked that the intervals within each day, month, year aggregation are up to us so long as we have a representative graph. So basically what this means is that we will go through, so imagine you get a stock trading app on your phone. Usually it displays a graph showing you the kind of price at the current time. And basically what we need to do is get enough detail to be able to fairly representative graph. If you don't have a fairly representative graph, then it's kind of pointless as a system. But the interviewer hasn't specified kind of which intervals we should use. So for each day, for example, we might decide to pick a 1 minute interval. It would give us quite a lot of data, be a very accurate graph, but it also might not be the most readable. So we might look at like a 5 or 10 minute aggregation, and there's certain technologies that we can use to go through and do that. So the last bit of this task is each of the APIs exposed have different requirements for performance. So the live API should be able to support like kind of 10 million requests a second. The historical API, about 1 million requests per second. Remember, based on the bits earlier on in our kind of brief, this is going to be a multi-region design, so we can assume that a lot of this traffic is going to be spread out across the globe. I think if this was a real interview scenario that you're actually facing, this is what I would be calling out to the interviewers and say, is it okay to assume that this is going to be spread out across the globe? And this is a really important point when you're doing interviews, is if you do make any assumptions, it's generally okay. Just tell the interviewer what assumption you're making and why you're making that assumption. The interviewer will generally come back to you and say if that assumption is not valid for this thing or the scenario that you're working on. So if this wasn't clearly a multi-region kind of scenario, then, and we said to the interviewer, hey, look, he said 10 million requests a second. I'm going to assume this is across the kind of globe. Then they would go, no, we haven't said anything about like kind of multi-region or anything like that. This is a single region, in which case your design is definitely going to change. So yeah, just make sure you call out all of your assumptions. Just double check the assumptions with the interviewer and make sure it's okay for the scenario that you're presenting. And you should be absolutely golden. So for each ingestion source has variable performance characteristics. Some stock items may burst into thousands of seconds. So think busy stock symbols like Apple or something like that. It's going to be a high throughput, very bursty in nature, something we just need to take into account. And then exchanges will be mainly active during working hours. So we can assume we're doing a follow the sun kind of model. So for example, the London Stock Exchange is only open in UK office hours, so 9 to 5, Monday to Friday. Same with currency pairs, like GBP only trades Monday to Friday, 9 to 5. So we can start assuming that, there's going to be periods of time where we can actually move a lot of the data processing to other parts of the globe, should we want to. Probably not going to do that in this design because we'll go way over like the 20 minutes and stuff that we would probably have in an interview. And for context, this is probably going to take longer than 20 minutes because I will be explaining stuff as I go through. And they're probably adding a bit more detail than what we would go through normally in an interview. But my aim here is to go through why I'm picking the different bits and pieces, so that you have the context and then you'll be able to take parts of this and present it and improve on it yourself. Okay, so let me switch to my whiteboard. We can come back and have a look at this design later on as well. Oops, if you had it to stream. Okay, so where would you even start off in this kind of design? For me, I like to start off with data ingestion. Data ingestion is going to be the point where we're probably going to have a lot of the discussion on this design. You will have a lot of discussion around the live API as well, but some of the technology choices, which I'll go through and explain why I'm picking them later, will make it a little bit easier for you. So there'll be less discussions around kind of that area. So if we're looking at the data ingestion, first thing we're going to be having on our diagram is going to have our exchange. And this might be the London Stock Exchange. Or it could be NASDAQ or something like that. I think for the purposes of these interviews, it doesn't really matter which exchange it is. You're just representing a concept called exchange. The next thing, given that the scenario has said that there is a bucket load of traffic that's come through, the next thing I'd be looking at doing is implementing some sort of load balancer. Now, two things that you may be looking at doing here, especially in AWS, is essentially two different types of load balancer that you can have. One is your traditional application load balancer, which is your layer 7 application, route stuff nicely through URLs. In this scenario, that's probably not quite what you want. You probably more want the network load balancer, or NLB. And the difference basically is which layer of the OSI model they actually go through and operate on. So an NLB operates kind of like TCP level, which pretty much all the exchanges run off of, because they run off essentially binary packets and stuff like that. For the most part, there will be some exceptions, obviously, but for the most part, it'll be kind of like TCP-based network load balancing. And the reason why we do this is any given stock could overrun a single server. So what we would have behind this network load balancer is a series of ingesters. Could probably think of a better name of it. But this network load balancer will be responsible for going out to these ingesters. And their responsibility is accept the packets, just validate there's no corruption, and then pass it off to something else. And in this case, I would pick something like Kafka. Now, if you're in an interview and you're picking something like Kafka, you have to come up with really, really strong reasons as to why you're picking it. Now, number one for me would be performance. So I haven't specified here that whether I'm running this on like bare metal essentially, or whether I'm using something like MSK, because that in reality would depend on a number of factors. If you're talking super high levels of performance, the chances are you're not going to be running a managed service like MSK. You probably will be running it on bare metal. But for an interview scenario, I would always try and stick with managed services where you can, partly because of the maintenance cost. And this is something you should always be considering in your architecture designs is, right, how much are you going to have in terms of maintenance in your design? So in the design, we obviously don't need to worry about like this exchange area. But we do need to worry about everything to the right of the exchange area. So we need to worry about the network load balancer. Now, this I probably would have as a managed service anyway, using AWS's NLB. The ingesters, these would be probably Fargate services. So I would be calling that out on here as well. And the reason why these would be Fargate services for me is I don't want to manage underlying hardware, but I want something persistent. Lambdas, if you're talking about these levels, I don't think they're a great choice, if I'm honest, because you need permanent connections everywhere. You don't want your connections recycling every 5 or 15 minutes, depending on your Lambda timeout. So you don't want to be breaking this Kafka connection, because this Kafka connection here is going to be TCP. This connection here is going to be TCP. And if you're on a Lambda and you're constantly breaking these connections, you're constantly introducing jitter and potential chances to fail, going back to the NLB, which is going to potentially fail going back to the London Stock Exchange. Now, this is kind of something that you can put into each region, because you can do like Kafka replication and stuff like that between different regions. So we are covering ourselves with that kind of multi-region aspect should we need to. There are obviously nuances around how we do this. So for this Kafka scenario, one of the things we have to keep in mind is, right, what's the structure of our topics? We wouldn't be able to have a single topic that said, here are all the stock trades, here are all the FX trades. We would be overloading those topics, and anyone that's consuming from them wouldn't have a great time. So what we're looking at doing, same reason why we're looking at this NLB, splitting out the traffic, so we want to split out our topics. So if we're looking at kind of like topic design, we'll be looking at, I don't know, calling our topic something like stocks, dot symbol, and then that would contain all of our data for that specific symbol. So it might be like, I don't know, Apple. Because what we can do then is any consumers that sit off the back, we can either subscribe to specific topics, or we can subscribe to something like stocks.star, and then get all the symbols. What it also means then is we can do different things like aggregations, which I'll go through now. So certain parts of the Kafka ecosystem allow us to run something called KSQL. And basically one of the things that we can do with this is have aggregations sitting on top. So if you got like, imagine like a time window here, where I've got 1 second, 2 second, 3 second, 4 second. We might have like one event's coming here. We might have couples coming in here, one here, and a couple there. One of the things we can do by splitting out our topics like this is we can say in KSQL, hey, every 5 seconds or every 6 seconds, give me a new aggregation. So I can then go and create a new aggregation table and go aggregation Apple. And that can give me that 5 second period, which we can then use for storing in other data sources. What this allows us to do is massively reduce the amount of load that's going to our underlying data store, such as InfluxDB. So that's what I'd be calling out in the Kafka kind of design. So we need to go and connect Kafka to our data sources. So let's go and do that. Let's clean up this because we'll need that later. So what happens after this back of Kafka? Well, we are going to want one or more Kafka consumers, because this load is going to be quite a lot. So, and they are going to go and pull from the Kafka source. And their job is to take the aggregations that we just mentioned and write them to a data source. Something like Influx. InfluxDB is a time series database, and we'll be able to assign kind of like tags to these kind of things, and then get aggregations of data kind of from Influx. So we can say, right, give me like a day's worth, roll up everything on a day, roll up everything on a week, and we get all the nice kind of lovely stats from it as well. So we're going to write into InfluxDB, but part of our problem space was not only for kind of historical data, we also need to get this data live within kind of like a second. So I would be hoping that this kind of chunk here would be done in kind of 2 to 3 milliseconds, something around that range. Our ingester really should not be doing too much here. The bulk of the time is going to be TCP connections and whatever your setting is on Kafka in terms of storage. So one of the things we didn't cover with Kafka is the ability for Kafka to say, when you write to a topic, how many replicas does it have to have of that data? So we could have like 5 replicas of this data if we wanted to be really, really secure. Otherwise, we could say, right, let's just store it once, because we can backfill this data from somewhere else. And that will reduce the overall amount of latency that you'll have. So we shouldn't be too far here. In this kind of scenario, InfluxDB will be slower than Kafka from my experiences. So I don't know, let's call it 20 milliseconds. Either way, we're not talking about a massive amount of time here, hopefully, because we are using aggregations from Kafka to store in InfluxDB, and then we'll get that onto the historical API later. I'm going to call it KCH for historical, because this is going to be our historical consumer. I personally wouldn't be using Influx for our live side of the database, which is what I'm going to go through and show now. So for the live side of the system, I'm going to create a new live Kafka consumer, and again, we'll probably have multiples of these consuming from different Kafka topics to go and update stuff. And the live Kafka consumer's job is to go and update Redis. So our live API, we're kind of in full control of. We know exactly what we're going to be doing here. So to complete the circle, we're going to have our live API. And that is going to pull from Redis. Now, in terms of instance sizes and stuff like that, we do have to kind of be mindful of what we have. But there's specific things that we can do with Redis, with key sharding and stuff like that, to make sure that we scale this globally. And I've verified this part of the design with a very, very large stock trading company, and this is pretty much exactly what they do in terms of live API talks from Redis. They have other bits and pieces up and around, but that's all their business logic. So now we've got our live API. We don't have any historical data on that live API. Wasn't mentioned in the specification, so we are all good. So what I'd be looking at now is, right, in terms of performance for this live API, we know that we can get this data into Redis very quickly. We know that the live API can hit Redis very quickly. So this, again, if I call it 2 milliseconds, I think I'm being generous. Typically in my real world usage, I've seen it a lot faster than that for a lot of things. So the bulk of the API work is going to be in authentication, whether it is even going to be authenticated. This is something you can go through with the interviewer and say, right, is this live API going to be publicly available, or is it going to be under authentication? Depending on the answer, depends on if you need to go and draw other boxes. So if it was under authentication, then you're going to need some kind of authentication system. So this might be Azure AD to do some of that, or it might be AWS Cognito. You'll also have to start thinking about rate limiting. How are you going to do that rate limiting? And if you use something like Cognito, there is certain things you can do inside of Cognito that help with rate limiting on API keys and stuff like that. But assuming that that stuff is all glorious, there is another optimization that we can make here, which is really going to help. Doesn't necessarily help the performance of you or of your system, but it does help the consumers of your system feel like they get a faster response out of your system. And this is a technology we're going to use in a couple of places. You may have heard of it before. I did talk about it in the last stream if you did see that. And this is AWS Global Accelerator, or I'm just going to call it GA. It's too long for me to write. And basically what Global Accelerator does is it talks to your APIs. So if we have forgot to add the load balancer in here, but we would have a load balancer in here as well, because we'd be running multiple instances of this API. But AWS Global Accelerator talks to your load balancer. Your load balancer can then be internal. It is not exposed to the internet at all. This is great for quite a few things. But AWS Global Accelerator to your load balancer, which is now internal, to your API, which is also internal, you get some extra protections. So you can then attach things like WAF and stuff like that to Global Accelerator, giving you DDoS protection and all that lovely good stuff that comes with Global Accelerator. But essentially, the way that it works is around the globe, AWS have different points of presence. And these points of presence are used for things like CloudFront. So you can get your CloudFront content out to your users really, really quickly and easily. So with this specifically, the reason why we're using it is because we don't want our users to go all the way through to kind of like the public internet and stuff like that to get to our servers. We want them to jump onto a fast connection wherever they are in the world. So we want them to connect to Amazon's network, and then we use Amazon's backplane to get their traffic and route to our services. Now, the other reason that we are going to take a look at Global Accelerator is for the multi-region scenarios that kind of came up earlier. So one of the features of Global Accelerator is it can do health checks against an endpoint. So we can expose an endpoint on this live API and say, hey, yes, I'm good to go over here. Or no, hey, I'm having a hard time over here. Please take me offline. So if this region suddenly becomes unavailable, Global Accelerator can fall over to a different region automatically. It's nothing you need to do in that. You can also obviously set up alerts. But as soon as your region comes back online, then what can happen is you can go to different areas. So if we're smart about kind of how we do things like our API design, going forward, so we might route certain traffic to like the European region. So if we've got like the London Stock Exchange, we can do that potentially at a DNS level. We can say this is the LSE API dot Contoso or whatever, and then /live. And then we can route all of the London Stock Exchange traffic to a specific area. I'm not sure where where's my arrows gone? Nope. Okay. So we can do different tricks like that. I can't remember off the top of my head whether Global Accelerator can do layer 7 routing or not. I would need to go and double check that in documentation, but maybe I'll leave that as an exercise for you guys to go and find out. But yeah, the multi-region capabilities of Global Accelerator are really, really awesome. And I thoroughly suggest you guys go and check it out because yes, it obviously does cost a little bit more, but if you're building a service where your users are globally distributed, I'll be adding this into basically every interview that has global users. And the reasons are lower latency, AWS's network, less jitter for the customer, faster experience. Boom. And who doesn't like a good user experience? So that pretty much wraps up the live kind of side of things. So now we need to go and tackle the historic side of things. Let's see that. Okay, a little bit up. So for the exact same reasons as I've just kind of gone through, I'm just going to go and put in AWS Global Accelerator again, because we want our historical API to be as fast as it can be. And this time I'm picking the ALB, not the NLB, because we want layer 7 routing. So if we want to go and do different bits and pieces, we can go and do that as well. So now we're going to go onto our historical API. I'm just going to draw a couple of arrows to simulate we'll have multiple instances of this. And that historical API is going to need to talk to our Influx database. And this, at least in this scenario that I showed earlier, there's nothing really here that kind of says, right, we need to have any kind of time limits on it or something like that. We may want to think about some kind of caching here for frequently accessed stuff. So for example, like today's the 3rd of August, right? The data for the 2nd of August is not going to change at all. So at least it shouldn't change at all. If you have, got a bit of a problem there. But the data for the 2nd doesn't change at all. So what we can do is we can cache that data a little bit closer and take the load off of the database. So if you remember, we've got these historical consumers that are going to be pumping the data in left, right, and center from our aggregation on KSQL. I'll try that down as well because I've got out there. So we're going to take these aggregations, pump them into InfluxDB, and this is going to be pretty write heavy. but we've also got a lot of read traffic as well. So for certain aggregations, we can almost prepare them ahead of time and have, I'm just going to call it a cache on here, whichever technology you decide to pick here. That's kind of up to you. So, for example, we might use something like Redis, and we go and check the cache. If it's not in the cache, we come back, we go down to InfluxDB, we get it, we pop it back into the cache, so the next person that calls it has that data available. And this does depend on what kind of aggregation levels you're picking for your historic API. But for something like 1 day, 1 day's worth, we could potentially grab that, pop it into the cache, store it under the stock symbol, and say, hey, for the 2nd of August for Apple, here was the data. Or for the 90-day period, here is the data. Now, the trick if you're going to do something like this for the caching is to make sure that you have a fixed sized step. So what we don't want to do is have you need to, if your graph, let's take your graph, it might be easier to explain like this. So if your graph on your UI is going to look like this, for example, what we want to do is segment this graph as much as we can into evenly sized points. So you might decide, okay, there are 100 points that are going to be shown on this graph. So, you're going to have to say like, right, for 1 day, it's going to be 100 points on this graph. For 30 days, I'm only going to show 30. Or you might say, here, I'm going to show 24, one for each hour, or something like that, every 30 minutes, whatever you decide to pick. But the key is here to be consistent, because that makes what we store in our cache then predictable. Anytime we have variability in the size of things, then that's when we start getting problems because we can't calculate it efficiently. And if you do put something like a cache in here, a couple of the questions that I would expect to be asked is, how big is this cache going to be? So if you're using something like Redis, right, how many servers are you going to need? Well, to work out that, you need to know how many data points you're storing, how big each data point is going to be, and more importantly, how many stock symbols you're kind of storing and saving. Again, if we're using something like Redis, or maybe something like Memcache is a bit better, they have different options for spreading that load out across all different servers and clustering capabilities. So that's definitely something that you'll be looking into. So whatever you pick for this technology here, just make sure you say, this is going to be a cluster. The data is going to be sharded. I'm using fixed points. And then like the keys for the cache keys will be something like stock symbol. I don't know, and then we'll just work backwards from there on the date. OA, 03, and then you can even add the time on, stuff like that. And then this way, this becomes a prefix key and you can scan by prefixes. So if I wanted everything in 2022, cool, I can just go and look up by that prefix. If I wanted everything in August, cool, I just take that away, go and add the next bit. So that can become really, really powerful for you to store in your cache. So long as you have your data segmented to fixed size, you can calculate it from there. So what else would we need to add in this design? For the historic API, then again, we might need to add some authentication system. I'm not going to go into too much detail there again. That's fairly standard and not kind of really the point of this architecture. What the interviewer is looking for in this architecture is, right, how are you going to go and ingest your data? How are you going to split your data sources between historical APIs and live APIs? Because what they're looking for you to do is say, right, which technologies are you picking? So just take this Kafka and KSQL one, for example. I suspect a lot of people that I've interviewed at least, would go for something like SQS. Now, in SQS, you can have a FIFO queue, which guarantees your ordering, but you are massively limited on performance. in compared to a non-FIFO queue. And if you go for a non-FIFO SQS queue, then you're taking the risk that things could fall out of order. Now, generally speaking, SQS is okay in giving you everything in order. But when you're talking anything with like financial data and times and stock ticks and stuff like that, it would not take the risk. So what you'd be looking to do is have an append-only store in this section, this kind of Kafka SQL API section. That append-only kind of logic allows you to go through and say, right, I'm absolutely solid as a rocket, and this is absolutely fine. The other technology that I would expect people to put in here would be event store. People love CQRS and event sourcing patterns, and they love to put event store in. But I can tell you from personal experience that event store does not scale at all. And that's primarily because of the way that people use it. I do think that event store would never be a good fit for this kind of system. Because of the way that stuff works, it's just generally not high performance. But generally, the problem with something, if you pick like event store in here, is when you're doing the subscriptions to the event store instance, there's basically two parts you can do the checkpointing on to say, where am I in the subscription? You can keep the checkpoints yourself in our historical consumers, for example, that we've got over on the right here. We could keep the checkpoints here, and it would probably be okay because it's then very similar, just slower version of Kafka at that point, and it will be good. But what I've seen a lot of companies do is in the central event store here, what they would do is keep the checkpointing logic on the master node, which means you can't use any, you can't scale out efficiently because all of the checkpointing is going into one area. Now, I've only got like 3 instances here and 2 instances here of all of these consumers. In reality, there's probably going to be like 10 to 15 in consumers because of the volume of data, which means that event store instance is going to get overloaded. And every company that I've seen that's tried to use event store, the technology, and try to make it scale, they've ultimately ripped it out like 18 months later. So this is why the interview process this is what it's here to design to do. It's designed to go in and say, right, what technology are you picking? Why are you picking that? We're picking Kafka because it's append only. It's proven to be fast. It's got the ability to do aggregations, and it's got the ability to do deduplications in that as well to give you accurate data. That makes it really, really great. It can do replication because we can just consume and set up replication to go multi-region if we wanted to, which is all win, 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 win. Then we've got InfluxDB. Why are we picking this technology? Again, it's a proven technology for the job. Now, I haven't played with AWS TimeStream myself. I've heard good things about it, and it looks pretty good, but I've not tried it myself. So it's one thing I'd also be hesitant in doing in an interview is going, right, I'm going to use this technology, but I've never used it before. Because if you do that, what you're basically telling the interviewer is, hey, I've got no idea really what I'm doing. This just sounds like the right thing to go and do. So that's what I'm going to go and do. Because what the interviewer is looking for is they're looking for concrete answers of why are you doing something. So I am picking InfluxDB because it's a proven technology. It's a time series database that easily allows me to do aggregations. An answer like that, the interviewer is going to go, cool. What they'll likely ask you to do is, right, how would you scale this to like double the load or something like that? And then that's when you start delving into the world of like influx sharding, maybe running multiple clusters, so on and so forth. Similar thing with Kafka. So taking a look at our other technology choices, NLB versus ALB. We kind of went over this earlier, but I think it's worth going over again. NLB, because we're dealing at a TCP level. We're not wanting to do any kind of layer 7 routing. We just need to distribute the traffic to split the traffic as early as possible. Anytime you're dealing with a requirement that is, I'd say, in the thousands of a second, if you're in the hundreds, you know, anything pretty much flies these days. But if you're starting to creep into the thousands per second, you're going to want to split that traffic as soon as you can. Easiest place to split it for us in this ingestion part of our pipeline, right at the start. So we create our load of instances. We can scale this. This can be auto scaling based on CPU load and all that kind of stuff. We can even do periodic scaling. So we know that in certain regions, things are going to happen at certain times of the day. So we can set this to auto scale 10, 15 minutes before opening time, and 15, 20 minutes after closing time, we can start scaling it back down again, saving us loads of money. Same with Kafka, depending on how we've set that up, we can scale that out. On all the consumers in that region, we can scale as well. So NLB distributes our traffic, splits it nice and early. When it comes around to global accelerator, using that latency, as we went through earlier. ALB, because we need layer 7 routing. And we can do target groups that we can do canary deployments on and stuff like that. So that's all fine and dandy. Again, live API, this will be on Fargate as well. Redis, why are we using that? Very, very fast key value database. We are looking at it for live API because we want to respond very, very quickly. We know, I say we know, it's proven to accept high volumes of input and give you high volumes of output as well. It's got capabilities to do things like key sharding. That's why we're going to be using Redis. So this live API is going to be very, very quick. And so we've gone through that. We've gone through the cache. I've purposely not picked anything there. We'd leave it up to you guys to kind of give your thoughts on what you would put in that scenario. Historic API, again, this would, for me, would be Fargate, auto scaling, lovely goodness. Global accelerator, exactly the same thing. ALB, exactly the same thing as before. So we've got pretty decent tech stack here, I would say. So what I'd be looking at now from an interviewer's perspective, if I zoom out a little bit, is I'll be looking at throwing you some curveballs. So if this is kind of like a typical kind of answer and structure that I would expect a senior software engineer to go through to. Obviously, the technology choices and some of the boxes will be different, but this kind of level of detail is what I would kind of expect for a senior software engineer. When you're looking at kind of the staff and principal level engineers, I'd be looking for them to go a layer deeper. So I'd be looking to go, right, say I'm in EU West 1, right? And that's my region. Here is my VPC layout, and here is what I would put in where. This is kind of the answer that I would expect from staff plus engineers. There we go, right. Inside of here, I'm going to have these are my public subnets. These are my private subnets. And these are my database subnets. So we're going in now into the realms of the networking side of things, because it's all very well and good designing this kind of solution, but a lot also comes into how are you going to secure all of this? So how are you going to secure these ingesters? How are you going to make sure that like your Kafka and your InfluxDB can't be accessed by the internet? Easiest solution, we put all of the databases like Kafka and Redis, all in database subnets, because the database subnets can then be limited to only accept traffic from the privates, and the privates can only accept traffic from the publics. And inside of the private ones, this is where all of our APIs are going to live, be distributed across. In our publics, this is where our ALB is going to live, our NLB is going to live. We'd also need an internet gateway. We don't have any outbound traffic, so we're not going to. Don't think we'll need it, but we'll also, if you had other things like if you're sending your logs outbound, you're going to need a NAT gateway as well. So those are kind of all the bits and pieces that we would have in place. If you're looking at more from an architecture lens, then right, we're going to be looking at what security groups do we have assigned in there. And at this point, we're starting to get a bit beyond what you would probably be asked in an interview. But just other things for you guys to learn is, right, what security groups are we going to have? Because, there are things that we need to consider about what rules, different things need to be applied, which areas we're going to apply security groups in. We need to think what knuckles we're going to be putting in. So generally speaking, developers kind of stop at the security group kind of level. They kind of forget about knuckles, and what knuckles basically are a very, very dumb version of security groups that you can put on and say, right, there's no SSH traffic anywhere in this VPC, and you can do it in different levels like subnets and stuff like that. The other things that I'd be looking at for a staff plus level engineer to be saying in the interview is, I'm going to be deploying these across different AZs. So this will be AZ1, this will be AZ2, and this will be AZ3. Or ABC, whichever. Depends on your cloud technologies, depends on which version and stuff they use. So what we're looking for the engineer to do in the interview is say, right, I'm spreading these across different availability zones. Why are we doing that? Well, because essentially each availability zone is essentially a data center that is within a certain geographical distance of the next data center, and a group of those generally makes up a region across different cloud providers. So what we're saying here is we can lose this entire data center, but we can still function off the last two. This gives us an element of disaster recovery. If we can even lose two. So one of the things that, if you ever did go into this kind of level of like VPC design and stuff like that, is these load balancers and network load balancers. These need to be in each of the availability zones. If they're not in each of the availability zones, if your single region goes down, then you've completely lost the region. Or you've lost access to your underlying services, shall I say. The other things that I'd be asking as an interviewer are, how are you going to observe the system? How do you know that this is working? This is an interview question that I basically always ask. So if you ever come and interview with me, first of all, say hi. And secondly, expect me to ask you, how do you know that the system is running after you deploy it to production? I will ask this question for anyone from like mid-level and above. And it is purposely vague because I want to see how you think about these problems. So how do I know that my ingester is actually ingesting? The short answer is metrics. Now, the more senior you get, like senior and staff and principals, I'd be expecting you to go into more detail of, right, what are you measuring? Okay, so I'm measuring the total throughput. And that became, okay, but that still doesn't tell me that this system is actually working. What tells me that the system is working? And generally the answer should be alerts. So what am I alerting on? Well, I'm alerting on that throughput or something in that metrics that we're capturing. So the other one might be latency. Latency is a pretty good one to always be measuring. Throughput, latency. And I'll be, okay, that's pretty decent. You're kind of alerting on those. What happens when you receive that alert? So after that alert, you're going to be wanting some kind of run book. And the run book should be crystal clear instructions for whoever is responding to the incident to say, go and check this, this, and this. This is why it's happening. These are the things to go and check. And here's a couple of different paths to remediation and what to do after remediation as well. And other things like which customer, like do we need to let our customers know, publish status updates, so on and so forth. If you're Staff Plus, then there's one more bit that I would be potentially looking at for different elements of the system. So let's take our load balancers down here on the live API. To me, for a Staff Plus engineer, I'd be wanting more than metrics and alerts. I'd be wanting synthetics. So if you're not familiar with what synthetic testing is, it's basically you have like a little actor that sits here, maybe in different regions, and they're constantly hitting your API. In a good way, they might be authenticated and stuff like that, but they're basically telling you what is the real world user performance that you're expecting from different regions around the world. And these synthetic tests can feed into things like scaling, health decisions. So, for example, if I'm being triggered from Brazil and I can't hit my European API for whatever reason, I might want to go and use some capabilities in Route 53 to go and geographically shift that traffic to a different data center or something like that. That's one of the powers in synthetics. You can make intelligent decisions on your infrastructure and keep a live view of what's happening in production. For get-only models, it's definitely a lot safer like this. And I would be putting in synthetics in all of the different critical paths. So like the live API, the historical API. I'm not massively worried about things like the ingester because that will be covered by the metrics and alerts. Synthetics offer end user experience. And synthetics feed back into your metrics and your alerts. They may create new metrics. They may create new alerts. What other curveballs would I look to throw in here? I think the other curveball that I would be throwing in here is long-term data storage. Given that these data streams publishing hundreds of thousands, millions of messages a day into the system, I'd be going, okay, so what are your retention periods? Have you even thought about retention periods? What about archiving? How are you going to add a BI workload? Unless you spend a proverbial ton of money, you're going to want quite a low retention on this Kafka, maybe a couple of hours, because of the amount of data that's coming in. Maybe you have to get away with a day or two, but you're not going to be having months or years worth of data stored in Kafka. InfluxDB, you'll be a lot better on, but you can't store endless amounts of data. You're going to need a limit on it. So how are you going to store it for 1 year? 2 years? How long do you need to store it for regulation purposes? So, for example, in the UK, we can't delete any financial records for 7 years. So that's emails, that's data. Any data that goes for a customer, we can't delete for 7 years. So what do we do about that? Well, there's nothing in the regulations that says we have to keep it in the same data source. So if somebody comes up to you and gives you a requirement like this, like you now have 10 years worth of data, like what are you going to do with it? That kind of style question. The simple answer is you're just going to archive it off to something like S3 and put it in infrequently accessed or something like that data storage tier. So if you're not familiar, S3 has different data storage tiers, gives you different performance and reliability benefits for different price points. So infrequently accessed still gives you really fast access, but doesn't break the bank in terms of storage. So you can start extracting out your data from InfluxDB, put it into S3 in some kind of sensible format. Could be pre-aggregated and all that kind of stuff. So that's what I'd be looking at doing there. And the beauty of that means that this database, in theory, unless you're adding new data points, should pretty much constantly remain a fixed size, give or take a few gigabytes as you start archiving stuff off. So generally speaking, unless like loads and loads of stock symbols and stuff get added in, it's going to be generally predictable kind of database size. Yeah, so that is a bit over the 20 or 30 minutes that you would probably get. I think when I did this design, I had 40 minutes all told to, or 40, 45 minutes to after the brief to kind of go through what I was doing, why I was doing it. In the actual interview that I did this one in, I actually used DynamoDB rather than InfluxDB. That was a choice I made in the moment and regretted it as soon as I said it, but I had to roll with it. And I think the reason why I picked DynamoDB rather than InfluxDB was the change notification system is a lot better. Inside of DynamoDB, I can apply automatic TTLs. It's obviously a managed service. So long as I set up everything correctly in terms of my partitioning strategy, then it's going to be a pretty good time. And again, I'd be using something like Apple 2022 is like the partition key, and then having some form of date and time as the aggregation key, and then reporting the aggregated results. Then when I'm looking up specific aggregations in the historic API, I can just go and say, essentially select the top 5 records from this query, order by this sort key. Job's good. Yeah, so I think the only other thing that I've got for this live stream today is one more curveball that I can see that would be added into this. And that would be what happens when we want to run other processes off of this data. So it's not going just to historical API or the live API or InfluxDB. We might want to do some real-time trading or something like that. The easiest point of you putting that kind of stuff into the system is Kafka. You just add a new consumer. You can either take the aggregated trades that we went through earlier, or you can go through and take the live kind of stock bits and pieces. If you didn't want to do that, yeah, the only other way that you could ever possibly do it is use traffic mirroring at this level, and essentially mirror the traffic twice to 2 different NLBs and then pipe it off to a completely different location. But to be honest, I wouldn't recommend doing that, not at this scale. So yeah, your easiest point would always be off Kafka, and then it's just a choice of where you're going to take the aggregated feeds from KSQL or the livestock topics. So long as you've got your topics kind of in order in terms of like, right, what your structure is, then you should be fine adding loads of consumers to it. Kafka is very, very good at that kind of read and write scenarios. So like, there's a load of stuff on LinkedIn's website around, or the LinkedIn engineering blog. If you've never seen that before, there's a load of like how we redesigned our log infrastructure on Kafka. We process millions upon millions of things per second. That's how I know Kafka can scale. Obviously, you would need to go into the deep depths of things, but yeah. So yeah, that's how I would probably go and answer this as an interview question. Hopefully everybody has learned something on there. So feel free to drop me questions either on Twitter or in the comments. More than happy to answer any other questions. Why I've done something in a certain way may not be clear. More than happy to kind of go through that stuff. So planning on doing more of these live streams kind of every week. I'll put up the stream kind of placeholder about a week or so in advance, just so that people can see when stuff's coming. I think probably the next one I'm going to do is more of a networking one, in terms of how to design a multi-account structure with AWS. There's definitely a few interesting things that should be considered when doing that, especially if you want to make it secure. So yeah, unless there's any last minute questions, thank you everyone for coming in and joining today. And thank you to the replay squad if you're watching this after the fact. Appreciate you. And yeah, definitely going to be doing more of these, and hope you enjoy the rest of your day, wherever you are in the world. So yeah, take care everyone. Thanks.